All right. Hi, everyone. Welcome to this Unreal Fest Bali technical talk, lighting in UE5, scaling for quality and performance. I say technical talk. It's not as technical as a lot of technical talk that happened this past yesterday and today. It's more aimed at artists and designers and technical artists to upgrade their workflow and to work a little bit better with performance in mind when they're placing lights, building worlds, building levels. There is an extremely good talk coming just after this one that is specifically on the lighting for Fortnite and for open world. So this is a very different talk. This one is for more focused small levels, and I will explain a little bit more what I mean by that. So on the agenda today, we have two main topics, optimizing for high-end devices, optimizing for low-end devices, and I will introduce those a bit with some context on the project that I worked on that kind of like made me use this kind of like double pipeline, and a conclusion that is more like a summary of the talk. All right. But first, you have to let me introduce myself. So I'm Alexis Argyriou. I've been based in Asia for the past 5 years. First 2 years in Shanghai, China, and then here in Southeast Asia. So that's me and my wife here in 2022. So it was our first day in Malaysia. We still reside there today, but we had some time in Vietnam, Singapore, and the Philippines. So I did a lot of things in the game industry over the past 15 years. I was first boots on the ground building open worlds for Ubisoft for a while. Then I was spearheading NetEase international game design departments, and I oversaw dozens of studios, European studios for Tencent HQ in Shanghai. There was a recurring theme, even if it looks a bit deconstructed. I was always firefighting. I was brought on teams that had projects that were difficult, or communication between the different departments was a bit broken, or the direction was constantly changing. So I took all those years of learnings, brought everything together to build kind of my own little consulting agency, where we act like a SWAT team that is brought in to help companies in need, and I'm kind of working as a producer. But really what I can do is that I can zoom out to understand those kind of like investors and strategic issues with studios, but I can also zoom in to the smallest details. So I'm fixing lighting optimization, which is why you're here today, is the kind of thing I'm doing as well. But I'm also dividing my time in two. During the day, I'm helping those publishers and studios with those like hardcore production issues. And at night, I'm working on my own solo game, like I'm sure many of you do. So let's start with a bit of context about the project. So earlier this year, I was helping in a competitive multiplayer first-person hero shooter. It's called BADMAD ROBOTS. It was built in a record time with a very small team. I will give you the tagline: fight hard to survive on streets overrun by broken, violent robots in a brutal post-human society. The game is super fun. It's two teams of 5 players fighting each other in urban areas that are kind of made to look like a city block from like a cyberpunk New York, you know. Each of the 8 characters have unique weapons and abilities, roughly basically following the DPS tank support kind of roles. But it's dark, it's colorful, it's edgy, there's a lot of teenage humor, burps and stuff. It's pretty cool. So I personally came in on the tail end of production when the release date was really closing in. The game was running fine on a 4090, but you know, if you ever read any hardware surveys, the user base with that kind of GPU is quite small. Anyone wants to guess how many users in percentage on the Steam hardware survey are using a 4090? What? Way smaller than that. It's 0.93% is using something like that or higher, right? What is the most used graphic card right now? 3060, 4060 laptop edition. It's kind of like the biggest chunk, right? I think those two together is like 10% altogether. Anyone wants to guess, like if you're looking between January and May, this percentage is dropping across the board for almost every GPU, right? Anyone wants to know which graphic cards are rising in percentage use? So you have like new cards, like 50 series, right? But really, the biggest strides are made by the integrated graphics. So here in Southeast Asia, I'm sure it's a surprise for no one, but people will start playing games. The gateway entry, the gateway drug to video games is like mobile games, right? You will see if you're driving around, you'll see like little kids behind the scooters of their dad playing mobile games, right, on their phone. But usually they will try to play the same games, so it would be a Fortnite or Roblox that are cross-platform, multi-platform, and they will want to play on a bigger screen, maybe with a keyboard and a mouse. So they would transition to use laptops, and usually they would have like entry-level laptops. So this is a huge, huge portion of the user base right now, and it's kind of important for us to take notice of that and be aware of this. Because when we're talking about optimization, we're usually thinking of like, low-end graphic cards or maybe a couple of generations ago. But really, we're also working with those really, really low-end devices, right? So obviously, the team that I was working with, they kind of like didn't want to lose this large chunk of the gaming population. They wanted to optimize the game to make it more accessible to kind of like the mass market. The gameplay also wasn't fully there. They wanted to overhaul like gameplay experience, upgrade the visual performance, visual presentation, like VFX, SFX, movement, lighting, all those kind of things, on top of improving performance. So I built a new kind of like art Bible, I designed a new sound theme, design language for the game, and then we went through our combined network to build a team of freelancers around me and to kind of like execute that new vision that included the performance, right? So on my side, I took on to overhaul the camera, the movement, level design, lighting, and performance, which is what you're here for today. So obviously, optimizations, if you're reading Reddit, it's a term that is thrown around a lot these days. And I learned that it meant a lot of things to a lot of different people. So to align with each other on the project, when we started, I defined 2 target frame rates, 120 FPS minimum for RTX 3080 and above, and 30 FPS minimum for kind of like laptop chipsets, right? Anyone playing at 120 FPS or above? Just one? What? 2? Now, once you try 120, you can't go back to lower. 60 FPS is so like a decade ago. So my initial plan was like this, to run Lumen on high-end devices and bake lighting for low-end devices. Why Lumen? Because our scene was kind of like covered with emissive, a lot of neon lights, a lot of reflective surfaces, a lot of bounce lights. We didn't have a lot of organic objects, organic surfaces like foliage. We had no foliage at all. So it's kind of like a perfect scenario for Lumen. And we also didn't have any dynamic time of day. Baked lighting was absolutely doable. It's been done for decades, so we can totally do that. We had 2 separate lighting scenarios. We had night and day. So we just had to be careful with the memory usage of those light maps. But we didn't have any like fancy transition between the night and day. We didn't have any blending between light maps. So it was really, really a good scenario for using baked lighting as well. However, I had one major constraint. We had no access to engine programming at this stage and no programmers on the team. So we had to rely exclusively on engine and project settings, post-process, command lines, CVARs. But it's not a talk on CVARs. I will show a few of them. There are 2 talks this Unreal Fest that are more dedicated on CVARs, and I'm sure they know much better about what they're talking about than me. So I invite you to check this out. I will show some examples, but I will repeat it during this talk. Those CVARs and those values are not to be copied because those are what works for us, and it will not work for you, for sure. The default epic settings in Unreal are kind of like trying to find this middle ground that might work for most people, but I really invite you to take a look and experiment by yourself. So I think that gives you kind of like a good overview of what the situation was in what I was dealing with. So we can now get in the weeds on how to solve this. So first was to solve the performance on those high-end devices. Step 1 was to establish a baseline to understand what was going on in this project. So I created a bunch of cameras, deleted all the lights that will revert from perforce later. But the idea was to figure out what is the base FPS at those particular spots, to compare also the no lights, lumen, and bake lights, to really have kind of like this ground truth. So then we used Unreal Insights, created a trace to keep a trace of this baseline in different spots, and also to have something to compare with later on. So everyone knows what is Unreal Insights? Yeah? Everyone who doesn't, there is a talk like next door that is about Unreal Insight. You should be there. But really check it out after and take a look because it's the most important tool. You cannot just look at a single FPS number on the top right of your screen and kind of make decisions based on that. You need the full picture. You need to know that every time you modify a value that changes your FPS, you need to know what exactly is it changing. Because when you're changing the value around, a lot of things can be affected, right? So when I was roaming around the map to put those cameras, I found one spot that was super bad. It was like 20% lower than the average on the map. So I kind of like focused my efforts on finding out what was happening here. And the goal was to bring this worst case scenario to 120 FPS, like we talked about earlier, right? I was like, if we fix this, we probably fix all the other spots as well. So anyone wants to know what's the issue here? What caused this much lower than the other? I will tell you later. I'll explain. Step 2 was to kind of like reevaluate the tech stack that we were using. Unreal comes with tons of solutions, and some are more suited to some scenarios, some cases, some are more suited for others. In our case, we kind of figured out that Nanite's base cost was not really worth the hassle for us in this kind of particular scene. We had great LODs, our triangle count was really nothing spectacular. We were also in 5.3, so a lot of non-Nanite compatible objects that would probably take more time to optimize rather than working on this kind of like double pipeline system. Probably more time consuming, and we just didn't have the bandwidth. So the main issue really in this levels was that we just had way too many lights for Lumen to handle. Also, it was 5.3, so we didn't have like this fancy magical mega light tech yet, right? At this time, we really had to make do with the 5.3. So step 3 was the cleanup. So cleanup stage. When I was checking this lighting costs, I kind of like found the usual trifecta of usual suspects. The first one was overlapping stationary lights. So it's massive resource hog in any bake lighting scenario. Once you have 5 or more stationary lights overlapping, the one with the smallest radius will start to cast dynamic shadows. Those have a huge performance cost, and it's kind of like useless to set up all the stationary lights if they're going to be in movable at some point, right? But even with Lumen, you will run it with issues because with Lumen, every light is dynamic by default. That's the system. And like I said, just too many lights for Lumen to handle. That will slow down the scene rendering without this magical mega light. I discovered also that a few static meshes weren't so static. So they had their mobility set to something else, like like we have a stationary or movable. And I found like almost 1,000 objects that were set to non-static, and that was the main culprit for this 20% drop in performance in this particular area. The whole building was made with movable meshes. So I don't know who here is checking for the staticity of static meshes, because that's never happened to me. So when I saw that, I was like, oh, okay, now we'll check every single time, right? And finally, you have to be kind of aware of the hidden VFX costs. So you have the VFX that are placed in the level, very easy to check. You roam around. You have the ones that are used by abilities that you will have to check the performance individually. For us, mainly, Niagara systems that were casting actual lights were a bit problematic. Things like embers or fire, most of them don't need to be casting shadows. So when I disabled that, it made a huge, huge difference for us. Especially if you're taking particle systems from Fab or from other places, you might have those like super fancy system with nice lights and it looks gorgeous. But be careful about this, the shadow casting in those VFXs. Usually it's not necessary, honestly. There's a lot more things we can say about VFX optimization, but at this point, disabling the shadows on those VFX was like more than enough. It was the biggest relief ever for the VFX cost. Step 4 will sound optional. But it will make your life so much easier. It's to normalize all your lights, the eye adaptation, the exposure values in your scene to match kind of like real life values. So you can look up the values in candelas or the value Lumen, which is very confusing. You can look up your favorite street lamp and kind of like use those exact same values in the engine. So anyone wants to guess what is kind of like the correct candela or Lumen value for a street light? It's super high. It's for a street light would be like 2,500 lumen for a small one, 10K for a big one, right? So if you have small values, you're off by a factor of several zeros. So it's a bit problematic. In this project, everything was set way too low. So we had some street lamps that had a brightness equivalent of like 1/10 of a table candle. So you can imagine that they had to boost up the exposure value to some crazy numbers, and that worked okay. You look at the scene, you have your dark spots, you have your bright spots, and it seems fine. But the Lumen kind of like likes to have like realistic values, right? When we solve those mismatching values, we remove like 80% of the lumen flickering we had in the scene. So you can't even imagine how much of a difference it made, because the default CVARs that are used in Unreal Engine are made to match with those realistic values. Also, we had very different values that during the day and the night maps. So we had 2 different sets of lights, which was kind of like a bit problematic. So I kind of like normalized everything, and then suddenly those light values work for day and night. So it works perfectly. The map also used emissive everywhere. So we had all those neon signs in a lot of places, and it really helps to have realistic lighting values, because your emissive settings in every single shader, every single material that has emissive in your scene, artists will have to tweak, like increase 0.1, because if they increase 0.2 the emissive, then everything glows like crazy, right? When you have realistic lighting values, your emissive at 1 is going to be basically like a flat color, 2 is going to glow, and 3 is going to glow 3 times brighter, and it's super easy to control, right? You don't have to be super precise with your emissive values anymore. Something I learned from working on Rainbow Six Siege, in a PvP shooter game, you don't want to have any pitch black areas. Players scream a lot. So here I increased the directional light intensity and the skylight values to kind of like lift those dark dead spots through the map. And in Unreal, it has also the benefits that it helps Lumen tremendously, right? Lumen likes to have this skylight and this directional light that kind of like do the heavy lifting in terms of like casting the GI. So try to remember that. So we know what Lumen is good at. There's a lot of documentation about it. We also know what it's not good at. And so step 5 was kind of like to make its life easier by fixing the typical kind of like pipeline bottlenecks. So we disabled WPO, warp position offsets, in all the materials in the game, especially for the Lumen scene, right? We switched to animated mesh in BPs instead, where we could. So super simple stuff like a rotating movement component for like rotating fans and those kind of things. We also replaced a lot of the translucent geometry with basic decals, because Lumen handles that perfectly. Also, it's a big misconception that I've heard a couple of times, but Lumen doesn't cast shadows. So I don't know if you're aware of that. Who knows here that Lumen is not taking care of the shadows? Just the light, just the GI. Very few hands up. I hope you didn't understand my question. But basically, yeah, shadows are not handled by Lumen itself. It's a different tech. It's the shadow maps. So virtual shadow maps or like normal shadow maps. Different tech. So here we can see in blue, it's the pure lighting costs. And in red, those are the shadows costs, right? Lumen's actual cost is really not that bad when you optimize it well. It could be negligible compared to shadow maps in some situations. So I focused a lot of attention to get those shadows working really well, to optimize as much as I can from them. After optimizing both together, we ended up at the cost like 0.83 milliseconds for lighting and 84 milliseconds for shadows. So it's quite good, but it was also a very short project, and I didn't have time or the bandwidth to really push it further. But you can really drop down those numbers to very good results. The default Lumen settings created quite a lot of flickering in kind of like low medium. So we built our own settings to kind of like fix that. We created our own default scalability setting file. Those are settings that work for us. Again, it won't work for you, so don't bother to copy them. It's really a per project basis kind of thing, right? There's no one size fits all, so you really need to experiment by yourself there. You should play with the virtual shadow map settings as well. It helps a lot. So for us, that was really one of the costliest thing in the entire rendering pipeline. There are not a lot of tutorials on which settings to improve, to change, so you will have to do a little bit of experimentation. But if you're using Unreal Insights, it will be very, very simple. So step 7 was to reduce the number of lights. So in areas with multiple lights, the performance really tanked. So in most cases, those were support lights that the artists were placing manually, like a ton of little invisible floating light bulbs that the artists placed to add the brightness in dark corners. My solution was destruction. I decided to basically keep only one light per area. So instead of like increasing the radius or intensity of the lights, I played with the indirect intensity. So basically artificially lifting up the GI intensity of those lights. It's kind of a hack. I will talk a bit more about this later, but that made a huge difference for us in terms of light coverage, how much light was covering the level, and it didn't really increase the costs at all because you're not increasing the radius, you're not increasing those kind of things, and it doesn't affect the light source itself, so it doesn't make the light source brighter, which is super important. Very, very cool to find this trick. I would say you have to learn to love spotlights. They're the cheapest form of lights. They're a lot easier to control. You can control their radius much easier, also much easier to cull. Yeah, spotlights are great. You really should use them. I can say that it will help you to light your scenes if you don't really think of light as this abstract glow of energy that is like, lighting your scene. If you think of it more like an interior designer or an urbanist, you can think of light fixtures as much as the light themselves. So what is casting my light? What is the object that is literally creating a light in this environment? It will help you to ground them. And also, if you do that, you will almost never use point lights because every single light that you see everywhere in your environment are always kind of like focused to affect some area. So they're all really spotlights in real life. Be super careful about dynamic lights. So I disabled all of them by default, and then I've been very specific and very intentional when I was bringing them back. I was really trying to put some love in those like narrow areas, narrow spaces with a lot of like shadow receivers. So shadow receiver is just a fancy way of saying like walls and floors. But basically it's where your shadows will be cast when you have a dynamic character, a dynamic object moving around, right? So if you have like, for example, a cliff and you have a light casting light like this, you have characters passing by, their shadows will never be visible because the shadow will be off the cliff, right? So those kind of things, those kind of areas is kind of useless. You have to think about areas where the shadows will kind of like dance on the walls. That's where the players will notice them the most. That's where they're most efficient, right? We can also, because it's a PvP game, we can also use those shadows to make the corners a bit more tactical. So when you have a player peeking, maybe the shadow will betray that their presence behind those walls. So this kind of thing is really cool because that matching your lighting with your gameplay features, right? Again, from my experience on building levels for Rainbow Six Siege, every single level that we built, we had only one dynamic shadow casting light per room. So if this game could have this success with this kind of constraint, I think you can do too. So this is what the Lumen scene looks like. It has a few destructible objects that are appearing black here, but it's fairly flat, fairly clean. We can see that we have highly saturated colors. The floor surface is normal, kind of like breaks up any of the spottiness we can have in lower end settings. Step 8, that was the crucial one. It's to reducing the number of shadows. So disabling the cast shadows feature was like my best friend on this entire project. There were a lot of ambient lights that were outside the gameplay area in what we call the vista. And they didn't really need any shadow casting. They were too far. They were just there to kind of light the background, right? So those could have their shadow casting disabled. Also, the max draw distance on the light was my second best friend for this project. I made sure that every light in the game had a max draw distance hard-coded. So I was going around and trying to find like what is the optimal minimal distance I could find for this light to avoid any pop-in, right? I also was disabling shadow casting on mesh LODs. That helped a lot. So basically, if you're not using nanite, you can go to your LOD settings for each mesh and manually choose if LOD casts shadows or not. So I did this a lot with all the floor clutter, a lot of the trash and those kind of things that didn't need to cast a shadow at a certain distance. That helped actually with the numbers of shadows casted. So not the quantity, like what's on screen, but really the number of them that are calculated. Then, when this was all said and done, step 9 was the lighting issues caused by bad level design choices. So the long line of sights will tend to kill your performance, and also the snipers are not fun in arena shooters, so we can fight about this after if you want, but I will hold my ground. So right here on the right, you have the light complexity debug view. So you can see that I tried to make it like taper off above the roofline. Also, I changed the colors, like what is like considered good is a bit more strict on this screenshot. So when you're in the ground, you really only see, like, you have high complexity of lighting, but it's really narrow in a space where you don't have a lot of things happening. And if you have something that is a bit further higher and you can see the distance, you will not have a lot of those lights there. They're completely hidden by the walls, by the structure of the level itself. So I had to introduce some level design changes to reduce this kind of like field of view in some areas. I added some blockers, some like signage that I lowered also to kind of like prevent the player from seeing too far up the streets. And of course, I like moved the lights around to kind of like be optimal about this. I also changed the intro and outro real-time cinematics, so we could use cheaper camera angles and we wouldn't see too much of like high like bird's eye view of the level. And yeah, this pipeline had a few hidden quirks. So if you don't know, but static lights in Lumen are completely ignored. So that's actually super useful for the next chapter. But it also means that all your necessary lights have to be stationary lights, if not movable. Just otherwise, they will just disappear when you turn on Lumen. They will appear in your bake lighting, but they will not appear in Lumen like at all. In this context, we have a static light, and it's not visible in Lumen, so we need to turn it to something else, a stationary light, for example. But here we can see that we have an overlap error, right? So those stationary overlaps will turn the stationary to movable, and movable lights are very expensive in the bake lighting scenario that we'll talk about later. So we can reduce the radius, but that kind of like defeats the whole purpose of it, right? This is the hack that I used kind of like throughout the project. We can increase the GI with the setting indirect lighting intensity. So this allows your light to bleed beyond its intended radius, but it doesn't really add any costs because it would also not cost any overlap. It's really just the GI that is like pushing it further than what it was intended. And it also doesn't increase you can see here, it doesn't increase the brightness of the source itself, right? The source is not visible in this screenshot. So in a nutshell, what we did is that I tried to use the smallest attenuation radius as possible. I think it's decoupled the attenuation radius and when the light would be hidden from view, when it would be completely culled. But the smallest attenuation radius possible will really affect your performance more than any other setting. Disable the cast shadows if it's not needed, and you can also abuse the heck out of indirect lighting intensity slider. So I don't know how epic people feel about this, but it was really working well for me. Like it's basically between 0 and 1, and I could crank it up to much higher, and it worked well in this setting. But it will also affect your fog. So if you have a fog like high-end, volumetric fog, you might want to disable the volumetric scattering because it will blow up your fog. All right, so how did we make it work even on low-end devices? So first off, I had to kind of like figure out how to switch between Lumen and non-Lumen in-game. We used the command line. That works. That's it. There was like no black magic involved. The engine takes care of disabling the light maps for you. There will still be a memory footprint, but it's kind of like negligible if you're using a kind of like high-end PC that can run Lumen in the first place. It will take care of disabling everything when Lumen is active, so that works. Step 2. Party like it's 2010. Brush off your baked lighting principles, right? Luckily, I started using baked lighting, so I just had to remember my login to Polycount and kind of like remember how to rebake lightings. What was true 15 years ago is still true today, luckily. So, having unique, non-overlapping, non-stretching UVs, avoid intersecting meshes in odd angles that might cause some lighting issues. But also it's 2025, and Unreal has this fantastic GPU-based light mask plugin that can allow you to bake lights for a whole level like this in just like a couple of minutes, which is a huge change because I remember at the beginning of my career, it was like the best excuse to go take a coffee break because your lights are building. Now it's not possible. Step 3, balance. So light maps can be a bit heavy. The memory footprints have to be kept in check. You don't need super high-res light maps for most of the time in a complex, kind of like well-lit scene. But disk space is less of an issue today than it was 15 years ago. Like my phone probably has like 100 times more storage space than my best computer had 15 years ago. So we only had 2 lighting scenarios, day and night. So we just did 2 bakes per map. We didn't have fancy transitions or anything. And also it's an FPS, so I try to allocate, not in this screenshot, in some areas I try to allocate more texel density and everything eye level. We also have grazing angle lighting a lot of neon lights that are put on the ground that will cause like this kind of like good gradients on the floor. So we had to increase a bit the textile density for the light maps on the floors. Lumen reflection, that was an actual godsend. I was really not looking forward to go back to reflection and capture spheres. It was a lot of trial and error to try to cover the map in this kind of like accurate reflections, given how contrasted our scene was. But you can see if you just like place a reflection capture like this, it's lumen and reflection captures. You can see that the contrast, the sky, it makes your scene a lot less grounded, a lot less realistic, right? We used screen space reflections for a bit higher than lower settings. It did a lot of the heavy lifting in those enclosed areas where we had a lot of contrasted, saturated light and those kind of things. So you see it's a huge improvement. It's not as good or as sharp as Lumen here, but it really does a job and kind of like makes itself forgot. This is what you need. You don't need to have something that pops too much. So what I cared about the most was parity, making the game as fair as possible, whether you were playing on a low-end machine or a high-end machine. So I wanted the bright spots to be bright in every scenario that we had, regardless of your settings. For me, that was the key thing, because it's a PvP game. We don't want to have areas that are just pitch black and someone think that they're protected, hidden, but they're really not. So that was really crucial for us. But also with all those wonderful tools that Epic is releasing, we tend to not cheat anything anymore. I've noticed that. So we use real lights, we use real reflections, real photo scans for everything. But don't forget, we make video games, right? So a game like this can make tons of money as well. You don't need to go like super deep into your optimization of like super high realistic lighting. They didn't have to go through the lengths I did on this project, and they're doing very successfully, and it's very happy for them. So with that in mind, my step 5 here was that games are fake. So if the first 35 years of the game industry taught us anything, is that we can do very pretty stuff for cheap. 50% of all the GI in my baked version was fake. I did this trick that the artists were doing before with adding a lot of little static lights to kind of like bounce those neon lights everywhere, and add a little bit more saturation. I faked almost every bounce light, every emissive with static lights for the baked lighting. And I could over-rely on them because they're completely gone from the Lumen setting. So they really don't interfere between the two. I don't even need to disable them in Lumen, it's just perfect. So if you take anything from this talk, that's it. Like try to cheat everything in your lighting, in your game. But it's also a talk on lighting, I know, but this last step, we'll talk a bit about the game thread. Once we had Lumen and shadow maps and reflections optimized, the GPU didn't really have that much work to do, so we could look back at the game thread that kind of like was bottlenecked on low-end machines. We had to switch to, when we were switching to static lighting, we disabled all the BP animated stuff, like rotating actor components on static lighting setting, activated WPO materials on like medium low setting, and kind of like put them behind like a detail mode in the shader. Yeah, so we did this for the fans and a lot of other things, because all those movable things in blueprints are on tick. So if you have a lot of them, that obviously cause a lot of issues that you might not see because you're so GPU bottlenecked, and then suddenly you're CPU bottlenecked, and then you see that that's causing issues too. So yeah, can be mindful about that. We also experimented with SSAO in medium settings, because the main thing that you will have problem with in static lighting is that your characters will not be as grounded anymore. They will need a dynamic light to cast a shadow and kind of like give the player the understanding of the relationship between their feet and the ground, right? Without shadows, you don't see this. So we do use SSAO in medium settings for characters, and that worked extremely well. That was pretty cheap actually, so we kind of like tried to use it everywhere. And that worked really, really well. So I went a bit fast, but in conclusion, you are supporting both traditional and Lumen baked lighting pipelines, so it is pretty involved, as you can see. I'm not sure it's the best way to do things. Maybe you can optimize Lumen to like crazy levels that it can work on super low-end machines. That was the route we chose to go with. It worked. It was involved, but it kind of worked. But if you go that route or the other, there is a ton of optimizations that are common between the two, right? So some would say it's just common sense, but control the number of dynamic lights that you have in your scene. Control the number of dynamic shadows. For us, it was the most important thing. Control your line of sight. Make sure you don't have areas that are way too big for the performance that you're aiming for. I believe personally that GI is the most important contributing factor to the final image quality. It's not that expensive. Both Lumen and Big Pipeline are, kind of like focused on doing great GI. My favorite good-looking game of all time is Mirror's Edge, and this game was, I don't know, it's like 15, 20 years ago now, and it still looks like $1 billion today, right? And everything is because of the GI in this game. So be intentional with your lighting. Less is more. I know it's an overused saying, but in this context, it matters a lot. Find what really matters for you. Think physically about the physical space that your game is set in. Where are your lights coming from? How can you make that more interesting for the player? How you can make each light valuable and adding something to the scene. Don't just like throw things around because you need a bit more brightness in some area. And so also think about what material would bounce your lights around. So if you have a little bit of reflectivity, a little bit of puddles, this kind of things that should bounce your light around and kind of like brighten up your scene a little bit more. All right, that's it for me. So I'm running those two things. You can reach out to me after the talk if you have any questions, or if you want my help on your projects, I'm all there for that. Also want to talk about my solo project, so if you are chatty, you can catch me outside. Thank you so much.